Good afternoon, everyone. Can you please remind me about the last thing that we did in the last class? What was that? What was the last thing that we did in the last class, Bete? Any one of you can please remind me about the last topic that we discussed in the last class?
Charge per unit volume.
Charge per unit volume, and after that, we didn't drive any result.
No, sir.
Sharing. Sonam,
Oh, oh, we did, sir.
we did, right? What we did was the electric field due to a wire, charged wire, right? If you can remember from the last class, we derived the result of electric field due to a charged wire which had a charge density of lambda. The last thing that we did in the last class was like this. This was a wire carrying a charge density of lambda coulomb per meter, and we derived the result of electric field at a point which was at a distance of r from this wire, and we got the electric field as lambda upon 2 pi epsilon naught r. Do you remember this?
Yes, sir.
Okay, this was the last thing that we did, or the last formula that we derived in the last class. Now we are in position to derive some few more results. I'll be deriving only one more result because the next result is not included in this year's 12th syllabus. And I'll tell you which result is not included or which derivation has been excluded from this. So in this year's syllabus, the exam that you will be giving this year, electric field due to hollow sphere, या spherical shell, hollow sphere, or you can call it as spherical shell. इसको इसको इस साल, due to the pandemic, this is removed from your syllabus. ठीक है? This year's syllabus doesn't contains this topic, which is electric field due to a spherical shell. So the only derivation which is required to be done is the electric field due to a charged sheet, because we will not be discussing about the electric field due to hollow sphere. So the only left topic in the derivation part of this Gauss's law is electric field due to infinitely long charge sheet. So write the topic: electric field due to infinite charge sheet. Write the topic: electric field due to electric field due to infinite charge sheet. Electric field intensity due to infinite charge sheet. This is what we are going to derive now. ठीक है सर?
Yes,
चलिए,
sir.
अब देखो, infinite charge sheet you can assume that it is obviously a very thin sheet. You can assume it as a paper of your book, simply can be considered as a sheet. ठीक है? And this sheet is infinite. Infinite means its size can be assumed as infinite in comparison to the distance at which you are finding the value of electric field. मतलब infinite का मतलब है कि ये जो चार्ज शीट है आपकी, उसके साइज को infinite आप मान सकते हो in comparison to the distance at which you are supposed to calculate the value of electric field. क्या मतलब सर? मान लो कि you are supposed to find the electric field at this point, somewhere here. So how will you find the electric field at this point? And let the charge density of the sheet is sigma coulomb per meter square. सर अगर आप किसी भी शीट को अगर आप सामने से देखो, if you take the front view of this charge sheet, not the side view, if you look at this charge sheet from here, this is the front view of the charge sheet. So this charge sheet will appear to be like this. Only the thickness will be observed by you. If you see it from front, so only the thickness will be observed, not the surface will be observed, right? I'll show you by this by just switching on my video. But before that, please note down this, whatever I have drawn on the screen, please note it down. See, in video, I'm showing you. Can you see me? Assume that this is the chart sheet, right? And if you observe the chart sheet from the side, so this is the side view that you can see. है ना? This is the side view of the chart sheet. Front view means you are observing this part. If you place this chart sheet like this, if you place this chart sheet like this and observe this chart sheet, so this will be called as front view. So if you see the side view, this will be the side view. And if you see the front view, this thickness will be appeared as the front view. Did you understand? If you observe the sheet from front, so this will be the front view, and side view means this, you will be observing this surface. This will be the side view, this will be the front view. Is it clear? Please tell me.
Yes, sir.
Yes, sir.
Okay. If you have understood this, then please let us drive the result. तो देखो, फिर से मैं शीट बना देता हूँ which is charged and had a charge density of sigma. तो आप देखो, अगर मान लो कि मैं फिर से आपसे ऐसे शीट ड्रॉ कर दूं, this is your charge sheet. This is the charge sheet having the charge density of sigma coulomb per meter square. This is sigma coulomb per meter square. This is the charge density, and this is infinitely long. So what we will do? How to drive the result of electric field? So we will be applying again the Gauss law, and to apply the Gauss law, you need to take some Gaussian surface, but there is no symmetric Gaussian surface which can enclose the whole of the sheet symmetrically. फिर से मेरी बात सुनो, ऐसा कोई Gaussian surface नहीं है जो इस चार शीट को मतलब symmetrically हर तरफ से enclose कर सके. And we need a Gaussian surface which is symmetric. और उसका reason आपको पता है कि we need a symmetric Gaussian surface just to make the electric field at every point of the surface as same, so that we can treat that electric field as a constant quantity and we will be able to integrate. अगर मान लो कि ऐसा नहीं है तो you will not be able to integrate because electric field will become variable. तो इस केस में हम पूरी शीट को एक बार में इनक्लोज तो नहीं कर सकते, and there is no such a symmetric Gaussian surface. तो इसलिए हम करते क्या है, we take a small portion of this chart sheet. Let's say मान लो कि यहाँ पर आपने एक small portion ले लिया chart sheet का, तो this small portion will obviously contain some charge, और इसको हम इनक्लोज करेंगे. तो इसको इनक्लोज करने के लिए व्हाट वी डू, वी टेक द हाफ ऑफ द सिलेंडर ऑन वन साइड ऑफ दिस चार्ट शीट एंड द रेस्ट हाफ ऑफ दिस सिलेंडर इज टेकन ऑन द अदर साइड ऑफ दिस चार्ट शीट. मतलब इसका जो दूसरा पार्ट है वो अदर साइड पे ले लेते हैं और एक पार्ट इधर ले लेते हैं. तो दिस इज हाउ वी टेक द गॉसियन सरफेस. मतलब अगर मैं इसको फ्रंट से दिखाऊं, तो मैंने आपसे बोला कि फ्रॉम फ्रंट यू कैन ड्रॉ लाइक दिस, राइट? यू विल ओनली सी द थिकनेस ऑफ दिस चार्ट शीट. तो अगर आप इसको इनक्लोज कर रहे हो इस वाले चार्ट शीट को, इफ यू आर इनक्लोजिंग दिस चार्ट शीट, तो आपको फ्रंट से ही ऐसा दिखाई देगा that you have taken a cylinder, half of the part of this cylinder is one side of this chart sheet and another half is on the right side of this chart sheet. This is how you will enclose and this would be your cylinder. Is it clear? ठीक है. मान लो कि इस सिलेंडर का जो एरिया ऑफ क्रॉस सेक्शन है, लेट दिस एरिया ऑफ क्रॉस सेक्शन बी ए, तो हियर इट इज आल्सो ए. अच्छा, बिकॉज द शीट इज चार्ज्ड, तो चार्ज विल बी on both the surface of the sheet. देखो, अगर ये चार्ज शीट है तो चार्जेस विल अपीयर ऑन बोथ द सर्फेसेस ऑफ दिस चार्ज शीट. इसका मतलब ये है कि सर यू विल बी हैविंग एन इलेक्ट्रिक फील्ड टुवर्ड्स राइट एज वेल एज यू विल बी हैविंग एन इलेक्ट्रिक फील्ड टुवर्ड्स लेफ्ट आल्सो. फिर से मेरी बात सुनो, बिकॉज इट इज टू फेज्ड चार्ज शीट which has two surfaces, so there would be the charges spread on both the surfaces. ठीक है, चार्जेस कहाँ कहाँ स्प्रेड होंगे? दोनों ही सरफेस पे चार्जेस स्प्रेड होंगे. तो इसीलिए, और बिकॉज चार्ज इज पॉजिटिव, तो इलेक्ट्रिक फील्ड विल बी इन बोथ द डायरेक्शन एंड इट विल बी अवे फ्रॉम द चार्ज. इलेक्ट्रिक फील्ड इधर भी होगा और इलेक्ट्रिक फील्ड इधर भी होगा. इज इट क्लियर? टेल मी यस और नो. अब इसके बाद क्या करूं? टेल मी, व्हाट शुड आई डू नेक्स्ट? अब क्या करना है बताओ. ऐसे बोलो. What should I do the next? Yes, you are saying something. क्या was saying? I couldn't hear you. Sonam Borgo, what should I do the next? Sonam stands in.
So normal.
Yes, of course, we should take normal on all the surfaces. So if we'll take the normal onto this circular part, this normal would be in this direction. And on the curved surface, the normal would be like this. Again, on this curved surface, normal will be upward along y-axis. And on this surface, normal would be pointing towards left. इसका मतलब अगर आप ध्यान से देखो तो this angle is 90 degree and this angle is also 90 degree. Hence, the flux due to the curved surface, flux due to curved surface is equal to 0 without any doubt. Flux due to the curved surface will be 0 since the angle between electric field and the normal is 90 degree. Hence, the flux due to the curved surface will be equal to 0. So there will be flux only due to the circular portion. अगर आप सर्कुलर पोर्शन का फ्लक्स निकालते हो नेट फ्लक्स तो इलेक्ट्रिक फील्ड आई हैव अज्यूम्ड इट एज ई तो ई मल्टीप्लाइड बाय द एरिया ऑफ दिस सरफेस एंड द एरिया आई हैव अज्यूम्ड it as A. Similarly, electric field on this side is E and the area I have assumed it as A. Yes, here also the angle will be 0 degree and here also the angle is 0 degree between these two. Why? Because in this direction also you are having an electric field. So the angle of the normal will be taken with respect to this electric field which is towards left. So EA plus of EA, this will be equal to twice of EA. This is the net flux that you will get from the first formula, which is electric field multiplied by area. Now, by Gauss's law, what do we know by Gauss's law? Gauss's law simply says flux will be equal to charge enclosed divided by epsilon naught. ठीक है? तो आपको क्या फाइंड करना है सबसे पहले? You will have to find the value of charge enclosed. And how will you calculate the value of charge enclosed? Who will tell me? How will you get the value of charge enclosed? Charge कितना enclosed होगा इस सिलेंडर के अंदर? How will you find that? देखो, charge density आपको याद हो sigma is equal to q by area. Do you remember that?
Yes,
तो
sir.
charge would be equal to sigma multiplied by area. तो charge को हम क्या लिखेंगे? Sigma, which is the surface charge density multiplied by the area. Because the portion which is enclosed is having this much of area and which is exactly equal to the area of the circular part of the cylinder. By area of the circular part of the cylinder and the portion of the sheet which is enclosed is also A. तो इसका मतलब चार्ज इस एरिया में कितना होगा? तो द चार्ज इन दिस एरिया विल बी नथिंग बट सिग्मा मल्टीप्लाइड बाय A. This will be the charge enclosed in this area. So hence, by Gauss's law, we can simply write flux as equal to sigma multiplied by A divided by epsilon naught. I hope you have got this equation number 2. Did you understand both the equation 1 and 2?
Yes, sir.
Note करो इसको. Then we'll write the final result. Done?
Done, sir.
Okay, so finally equate these two equations to get your final result. And I'll be doing this here. Because from 1 also you have got the value of flux, from 2 also you have got the value of flux. So you can simply equate the two equation because both are giving you the value of flux. So twice of EA will be equal to sigma times of A upon epsilon naught. A will be cancelled out by A. So electric field will be equal to sigma upon twice of epsilon naught. This is the value of electric field due to a charge sheet. And remember, the electric field due to a charge sheet is independent of the distance at which you are finding this. There is no way written the distance at which distance you are finding this value of electric field is not mentioned in the formula. इसका मतलब है कि चार्ज शीट का जो इलेक्ट्रिक फील्ड है, इलेक्ट्रिक फील्ड ड्यू टू अ चार्ज शीट is independent of the distance at which you are measuring this value of electric field. It is independent of that. It only depends on the charge density and the permittivity of the medium in which the charge sheet is placed or kept. Clear? हो गया सर?
Yes, sir.
ठीक है, moving on. So we have derived the result for electric field due to a charged wire and we have derived the result for electric field due to a charge sheet. तो हमने charge sheet का भी result derive कर लिया और wire का भी result derive कर लिया. The third we are not going to discuss because it is not included in this year's syllabus. क्योंकि आपको पता होगा कि 30% of the syllabus has been reduced. ये पता है सबको?
Yes, sir.
12th में 30% of the syllabus is deducted or it is reduced. तो इस चैप्टर में जो रिडक्शन हुआ है that is the electric field due to the hollow sphere या spherical shell has been reduced. This time you will not get any question or the derivation of the electric field due to a hollow sphere. तो इसलिए हम उसको डिस्कस भी नहीं कर रहे हैं, टाइम खराब भी नहीं करेंगे हम. तो इस पे हम एक दो क्वेश्चन सॉल्व करते हैं सर बेस्ड ऑन द फॉर्मूला दैट वी हैव जस्ट ड्राइव्ड, वन फॉर द चार्ज शीट एंड अनदर फॉर द चार्ज्ड वायर. तो इससे रिलेट करके हम फॉर्मूले को रिलेट करके एक दो क्वेश्चन सॉल्व करते हैं जिससे हमें एक आइडिया बन जाए. तो देखो इसके लिए आप ऐसा अस्यूम कर लो कि लेट्स से वी आर हैविंग अ चार्ज्ड वायर. लेट्स से वी आर हैविंग अ चार्ज वायर. बहुत आसान सा क्वेश्चन पूछ रहा हूँ. This is infinitely long charged wire and lambda coulomb per meter is the charge density of the wire. And there is a charge placed at this distance. मान लो ये r distance पे एक charge रखा हुआ है q. आपको बताना find the force on q due to wire. आप इस वायर के कारण ड्यू टू दिस वायर फाइंड द फोर्स ऑन द चार्ज q. आप इस वायर के कारण बिकॉज ऑफ दिस वायर आप फोर्स पता करिए कहां पर ऑन द चार्ज q. क्लियर?
Yes, sir.
How will you do that? Who will tell me? How can we find the value of force? कौन बताएगा? सर आपको एक बात याद होगी, फोर्स इज इक्वल टू चार्ज. You must remember a formula: electric field is equal to force divided by charge. Do you remember that? This was
Yes,
the
sir.
relation between electric field and the force. So if you want to find the force, you can simply multiply the charge with the electric field. That's it. If you know the value of electric field at a point, you just multiply it with the charge at that point, you will get the value of force. So we know that due to a charged wire, the electric field at this point should be equal to lambda upon q, sorry,
2
lambda
pi.
upon 2 pi epsilon naught multiplied by r. So what will be the force? Simply the product of the two. So lambda q divided by 2 pi epsilon naught r. This is just the result of the force that will be experienced by the charge q placed at a distance of r from this infinitely long wire. अब ये मैंने क्यों बताया? Because I had to give you the another question based on this. मतलब I just remind you the formula of force in terms of electric field. Now we are in position to solve another question where you will have to apply this formula. मैं इसको erase कर रहा हूं. Okay. Now my next question is कि I have this infinitely long wire. Again I am having this infinitely long wire of lambda coulomb per meter, of the charge lambda coulomb per meter. I'll give you some values of this lambda and all those things, but पहले तो ये समझो lambda. ठीक है, the value of the lambda that I'm giving you is, the value of lambda is equal to 4 into 10 to the power minus 4 coulomb per meter, and a dipole is placed near this charged wire This dipole has a charge of 2 into 10 to the power minus 8 coulomb, and here it is a charge of minus of 2 into 10 to the power minus of 8 coulomb. ठीक है? This, या इसको minus ले लो, इसको plus ले लो. This two charges are separated by a distance of 2 millimeter, and this first charge is at a distance of 2 centimeter from this wire. ठीक है? आपको ये दिख रहा होगा कि the arrangement that is kept near this charged wire is a dipole. Can you see that? It's a dipole.
Yes, sir.
तो आपको बताना है कि what will be the force, find force on dipole due to charged wire. इस charged wire के कारण, मतलब due to this charged wire, you have to calculate the force on this dipole. मैं आपको बस एक hint दे देता हूं कि आप एक बात याद रखिए कि 2 centimeter is undoubtedly greater than that of 2 millimeter. That means you can neglect 2 millimeter with respect to 2 centimeter. अब कौन मुझे बताएगा how should we solve it? How will you find the force on this dipole? What would be the method? How will you approach this question? Anyone? Can anyone suggest me a method how we will get the value of the force on this dipole due to this infinitely long wire? Can anyone suggest me some method? No one. Bolo.
Finding the electric field.
I didn't get you. Can you please repeat?
Finding the electric field intensity due to the dipole.
No, why should we find the electric field intensity due to the dipole? We are supposed to calculate the force on the dipole. Yes, you can even find the value of electric field intensity, but that would be a difficult task to find because you will have to apply the formula of the electric field. But the point is in that case you will be finding the force on the whole of the wire. We are not supposed to find the force on whole of the wire. What we are supposed to do is we have to find the force on the dipole. And remember, this wire is not a point particle or point charge. So you cannot directly use the formula of force is equal to charge multiplied by electric field for the whole wire because it is not a point particle. It is called as continuous body. So for that, you will have to apply the method of integration. So it will become quite difficult. So don't go that way. Go this way. कि देखो ये charged wire का electric field, we know the formula of electric field due to the charged wire, yes or no?
Yes, sir.
So of course there is some electric field due to the wire. So if I have to find the force on this negative charge, so I will write the force on this charge will be equal to Q multiplied by the electric field at this point. Similarly, if I have to get the force on this positive charge, I will write Q multiplied by the electric field at this point. Did you understand? Acha, what would be the direction of electric field due to this wire? The direction of electric field will be like this. The force on this charge will be opposite to the electric field because it is negative, and force on the positive charge will be in the direction of electric field because it is positive. Did you understand? So what we are supposed to do is just find the value of forces on this negative charge and positive charge by applying the formula of electric field, and then you can subtract the two forces to get the net force on this dipole. तो पहले तो आप नोट कर चुके हो ये क्वेश्चन so that I can further solve this. नोट कर चुके हो ये क्वेश्चन? टेल मी. क्वेश्चन इरेज कर दूं मैं?
Yes.
Yes, sir. You can.
ओके अब मुझे आप बताएंगे. सो यू नीड टू अनम्यूट योर माइक एंड जस्ट रिस्पॉन्ड टू माय क्वेश्चंस. सर मैं आपसे बोलूं what is the force on the negative charge? So how will you calculate force on minus q? What will you write? You will write the charge multiplied by electric field. Am I correct?
Yes.
The charge multiplied by electric field. The formula for electric field, you will write it as lambda 2 pi epsilon naught multiplied by r, where r is the distance of this negative charge from the wire. So F minus Q will be written as equal to charge. Charge is how much? 2 into 10 to the power minus 8 of for this negative. Remember, you don't need to put the negative sign because you are calculating the magnitude. Multiplied by lambda. Lambda is given, see, 4 into 10 to the power minus 4. Okay, what will be the value of 1 upon 2 pi epsilon naught? 1 upon 2 pi epsilon naught will be equal to what? So see, 1 over 4 pi epsilon naught is equal to 9 into 10 to the power 9. Am I right? If you want to
Yes,
find
sir.
out 1 upon 2 pi epsilon naught, what should you do to make this 1 over 4 pi epsilon naught as 1 upon 2 pi epsilon naught? Don't you think we should multiply it by 2?
Yes, sir.
If you'll multiply both sides by 2, what will you get? You will get 1 upon 2 pi epsilon naught, and this will be equal to 18 multiplied by 10 to the power 9. Did you understand?
Yes, sir.
So 1 upon 2 pi epsilon naught is 18 into 10 to the power minus, 18 into 10 to the power 9 divided by R. R is what? This distance of negative charge
Mm,
from this charged wire. And how much is that? It is 2
2
centimeter. Should I
centimeter.
put it as 2? Should I put it as 2 centimeter or should I convert it into meter?
Convert it into meter.
Of course, we should convert it into meter. So 2 into 10 to the power minus 2 meter. From this, we can get the value of force on the negative charge. Of course, you can cancel out these two. Okay. This will become 72 multiplied by 10 to the power 9 and 10 to the power minus 8 will become 10 to the power 1 into 10 to the power minus 4 and 10 to the power minus 1 will become 10 or minus 3, 10 to the power minus 2. This will become 72 into 10 to the power minus 1, or this will become equal to 7.2 Newton. Did you understand the force on this negative charge? Please tell me yes or no.
Yes, sir.
Okay, note it so that we can find the value of force on the positive charge. Note it fast. Is it done?
Done, sir.
Okay, the same way we should find the value of force on the positive charge. Okay, the only difference will be what? The only difference will be of this distance, right? So how will you write the distance? So I'm erasing this part now, and I'll just here there will be a difference, and we will write this difference as see, ये 2 centimeter, so 2 into 10 to the power minus 2. This is 2 millimeter. If you convert it into 2 into 10 to the power minus 3 meter, if you convert it in millimeter into meter, it will be 10 to the power minus 3. तो इसका मतलब है ये हो जाएगा 2 into, अच्छा yes, 2 into 10 to the power minus 3 को how can you write? You can even write this as 0.2 into 10 to the power minus 2 if I'm not wrong. So this can be
Yes,
written
sir.
as 0.2 into 10 to the power minus 2. Is it clear?
Yes, sir.
So F plus of Q will become equal to, don't cancel out this 2 now. So this will become equal to 8 multiplied by 18 into 10 to the power minus of 12. So this will become 10 to the power minus 3. This will become equal to 2.2 multiplied by 10 to the power minus 2. ठीक है sir? So now you can multiply 18 and 8 and you can divide it by 2.2. So what you will get? 18 into 8 divided by 2.2 will be equal to 65.45 approximately. So 65.45 into 10 to the power minus of 1, which can be written as 6.54, or you can take it as 5 or make it as only 65.4. So this will be equal to 6.5 into 4 newtons. This is the force on the positive charge. Clear? So you have got the force on negative charge, you have got the force on positive charge. So how will you get the net force now? So to get the net force, you will just subtract the two forces because the forces are in opposite direction. Is it clear? Because force on the two charges are in opposite direction. इस पे जो force लग रहा है that is in this direction, and इस पे जो force लग रहा है this is in this direction. So F net will be simply the difference of the two. You will write F minus of Q minus of F plus Q. You will subtract the two forces. You will get the net value of force. Is it clear? Please tell me yes or no.
Yes, sir.
Okay, इसको नोट करो, फिर मैं आगे बताता हूँ. Done. सर आगे बढ़े अगर आपने इसको नोट कर लिया हो तो.
Yes, sir.
Okay, so I'm erasing this. Let's go to the next question now. The next question is, I'm writing the question on the screen. Please go through it. A charge of 17.7 into 10 to the power minus 4 coulomb is distributed uniformly over a large sheet of area 200 meter square, right? Calculate electric field due to the sheet. You have a sheet which whose area is given to you as 200 meter per square, and the total charge that has been spread on this sheet is 17.7. So what you are supposed to calculate is you have to supposed to calculate the value of electric field due to this charge sheet. Can you please solve this for you? कैसे करोगे कोई मुझे बता सकता है? How will you solve or how will you attempt? कोई मुझे बता सकता है? How will you think of solving this question? तो देखो बेटा, सिंपली आपको मालूम है कि इलेक्ट्रिक फील्ड ड्यू टू द चार्ज शीट इज इक्वल टू सिग्मा डिवाइडेड बाय 2 एप्सिलॉन नॉट. एम आई राइट? टेल मी
Yes,
यस और नो.
sir.
If what is this sigma? Sigma is the charge density. And how do you find the value of charge density? So sigma can be written as equal to charge
Q
upon
by
area.
A.
Very good. Q by A. To find the value of sigma from this Q by A, so Q is 17.7 into 10 to the power minus 4 divided by area. Area is equal to 200. If you'll simplify this, you will get the result as 8.85 into 10 to the power minus 6 coulomb per meter square. So I have got the value of sigma. Now what I should do? I just put the value of sigma in this and value of epsilon naught in the formula of electric field. So sigma you will write it as 8.85 into 10 to the power minus 6, and the formula of epsilon naught is 8.85 into 10 to the power minus of 12, right? From this 8.85 cancelled out. If you'll take this in the numerator, this will become equal to 10 to the power 6 divided by 2, or you can write this as 0.5 multiplied by 10 to the power 6, or you can write it as 5 10 to the power 6, sorry, 10 to the power 6, or you can write it as 5 into 10 to the power 5 Newton per coulomb. Did you understand? Please tell me.
Yes, sir.
Yes.
I just found the value of sigma by the formula of charge upon area. And after getting that, we just put the value of sigma in the formula of electric field due to the charge sheet. I will solve one more question and then we'll move to the next topic. So let us solve one more question based on this and then we'll go to the next topic. Can I erase if you have noted this? Can I erase this now?
Yes, sir.
ठीक है, I'm writing another question on the screen. Please go through the question. Question ये है कि a charged particle having a charge of -2 into 10 to the power minus of 6 coulomb is placed close to a non-conducting plate. Don't get confused with this non-conducting plate. We will discuss it later on. तो आप तो यही समझो non-conducting plate भी कहा है क्वेश्चन में, तो it is simply the charge sheet. ठीक है, having a surface charge density of 4 into 10 to the power minus 6 coulomb per meter square. ठीक है, आपको बताना find the force of attraction between charge and plate. Can you please tell me how can we solve this question? Who will tell me how to solve this problem now? How will get the value of force between the charged particle and the charged plate? How we will calculate the force?
Charge electric.
First, we will
Yes,
find
bolo, bolo.
electric field.
Very good. And we will simply multiply that electric field with the charge, because force is
Yes, sir.
simply equal to what? So of course force is simply equal to charge multiplied by electric field. तो force की value को हम लिख सकते हैं charge, that is I'll write it as charge only, and here we will put sigma upon 2 epsilon naught. This is what we are supposed to do. Just put all the values in this formula. So the value of the charge is given as 2 into 10 to the power minus of 6 multiplied by the charge density, which is already given as 4 into 10 to the power minus 6 divided by 8 2 multiplied by 8.85 into 10 to the power minus of 12.
Plus of.
ठीक है?
Yes, sir.
Minus of 12, right? And now you can solve this. So from here 2 and 2 will be cancelled out. 6 and 6 will become 10 to the minus 12. मतलब इसको आप ऐसे लिख सकते हो 4 into 10 to the power minus of 12 divided by 8.85, and this 10 to the power minus 12 when taken to the numerator will become 10 to the power plus 12. So you can cancel out this 10 to the minus 12 and 10 to the power plus 12. Did you understand? You can simply cancel out these two. So finally what you will be left, with this 4 and 8.85, which you will solve. You will get 0.45 Newton approximately. This will be the value of the force that will be experienced by the charged particle due to this charge sheet. Is it done now?
Then, sir.
Okay, so finally now we have completed this first chapter, which was electrostatic force and field. We have done that chapter completely now. We discussed the Gauss's law, we discussed the electric flux, we discussed the electric field and all these things. So we have completed this first chapter. Electrostats contains two chapters. First chapter was electrostatic force and electric field, which we have already completed. Now we will start the next chapter, which is electrostatic potential and capacitance. It is also the part of this unit, which is electrostatic. ये भी इलेक्ट्रोस्टैटिक यूनिट का ही पार्ट है, बट दिस इज द सेकेंड चैप्टर ऑफ दैट यूनिट। तो इस चैप्टर का नाम लिख लीजिए, इलेक्ट्रोस्टैटिक पोटेंशियल एंड कैपेसिटेंस। इलेक्ट्रोस्टैटिक पोटेंशियल एंड कैपेसिटेंस, इलेक्ट्रोस्टैटिक पोटेंशियल एंड कैपेसिटेंस, इलेक्ट्रोस्टैटिक पोटेंशियल एंड कैपेसिटेंस। ठीक है, तो आपको बेसिकली इलेक्ट्रोस्टैटिक पोटेंशियल क्या है उस पर डिस्कशन होगी हमारी, and how we get the formula of electrostatic potential and all these things. Electrostatic potential energy we will discuss in this chapter. ठीक है, and then we will discuss the arrangement which is known as capacitor, capacitance क्या होता है, capacitor क्या है, and all those things. But before I start this chapter, can you please tell me, do you remember the something called as work, a quantity known as work? Do you remember that or not?
Yes, sir.
Okay, good. Whenever you exert some force on a body and the point of application of force moves, so in that case, we simply claim that the force is doing some work, and that work is calculated by force and displacement, by the product of force and displacement. So whenever you apply some force to a body, and if the body or the point of application of force has moved or it has been displaced, so I will simply claim that the force has done some work, and that work will be calculated as a product of force and displacement. Or agar if I say more precisely, so that product would be the dot product between the force and the displacement. Force or displacement का जो dot product है, force or displacement का जो dot product है, that will be simply called as the work done by that force in displacing the body by some. तो पहला पॉइंट लिखो, इलेक्ट्रोस्टैटिक पोटेंशियल डिफरेंस. राइट द फर्स्ट टॉपिक, electrostatic potential difference. Write the first topic, electrostatic potential difference. Electrostatic potential difference. पहला टॉपिक लिखो, electrostatic potential difference. लिख लिया?
Yes, sir.
Now, sir, if we assume that there is some charge and let this charge be q and it is positive, मान लो कि ये एक चार्ज है और ये चार्ज पॉजिटिव है एंड इट इज प्लेस समवेयर, राइट? और अगर मान लो कि इसके पास मैंने कोई दूसरा चार्ज रखा है, लेट दिस अनदर चार्ज बी हियर एंड इट इज आल्सो पॉजिटिव. ये जो दूसरा चार्ज है ये भी पॉजिटिव है एंड इट हैज बीन प्लेस समवेयर हियर. ये दूसरा चार्ज पॉजिटिव है और इसको भी हमने यहाँ कहीं रखा है, राइट? तो ऑब्वियसली आई कैन सिंपली से दैट दिस चार्ज ऑफ दिस q which is a small q, this charge will obviously experiencing some repulsive force due to this charge. ठीक है, जो चार्ज कैपिटल Q है, ड्यू टू दैट, इसको मैं Q नॉट कह लेता हूं तो थोड़ा ज्यादा अच्छा कह सकते हैं कि दिस Q नॉट विल एक्सपीरियंस सम रिपल्सिव फोर्स ड्यू टू दिस चार्ज Q. ये तो ऑब्वियस है, इस पे एक फोर्स लग रहा होगा एंड दैट फोर्स ऑफ रिपल्शन वुड बी एक्टिंग ऑन Q नॉट. तो बेटा मुझे एक बात बताइए कि ड्यू टू दिस फोर्स ऑफ रिपल्शन Q naught will move towards the charge Q or it will move away from the charge Q? In which direction do you think Q naught will tend to move?
Away
Towards
from
the
the
source charge or away from the? Of course, away from the source charge because of this force of repulsion. तो मैं ये कह सकता हूँ कि it is experiencing an electrostatic force of repulsion and due to which it will tend to move away from the source charge, right? And let me call this as point A. ये point A पे रखा हुआ है already. अब अगर मैं आपसे ये कहूं कि if I want to move this charge A in a direction opposite to the direction of electrostatic force of repulsion, तो don't you think I'll have to exert some force to balance this electrostatic force? भाई ये खुद से तो नहीं मूव करेगा. आप इसको अगर मूव कराना चाहते हो against the electrostatic repulsion, तो you will have to exert some force on the charge Q naught just to make it move away from opposite to the force of electrostatic. और वो फोर्स जो आप लगाओगे, that force will be called as external force which is applied by you on this charge to move it against the force of repulsion. तो सर अगर आपने ये फोर्स लगाया and by applying this force if you have moved this charge from one point to another point, so of course this force of yours will do some work on the charge in moving it from one point to another point. Is it clear? कि ये वाला जो फोर्स है obviously it will perform some work on the charge in moving it from point A to point B, because you have applied a force on this charge, and hence it will perform some work on the charge in moving it from point A to point B. Is it clear? The work
Yes, sir.
done by this force against the force of repulsion divided by the charge which is being moved is known as potential difference. ये जो आप वर्क कर रहे हो to move the charge from one point to another point in this electric field against the force of repulsion, that work divided by the charge which is being moved is known as potential difference.
Potential difference.
That work can be done against the force of repulsion or against the force of attraction. For example, I'll take the another example. Let's say this charge is positive, and this time the charge that I am placing is not positive, but it is negative. It is minus q naught. So undoubtedly, this charge would be experiencing a force of attraction, that is the electrostatic force of attraction, and this will tend to move towards this charge capital Q. If you want to move this charge from this point to some another point against the force of attraction, if you want to move this charge from point A to point B against the force of attraction, again you will have to apply an external force in this case. आपको फिर से एक external force लगाना पड़ेगा, और ये एक्सटर्नल फोर्स आप कैसे लगाओगे, तो ऑपोजिट टू दैट ऑफ इलेक्ट्रोस्टैटिक फोर्स आपको ये एक्सटर्नल फोर्स लगाना पड़ेगा. तो ये एक्सटर्नल फोर्स अगेन विल बी डूइंग वर्क, and this time you are doing this work against the force of attraction, because this electrostatic force is the force of attraction, and you are doing or performing work against the force of attraction. So again you are doing some work ultimately. So either you perform work against the force of repulsion or against the force of attraction to move the charge from one point to another point in the gravitation electrostatic field. That work done per unit charge is simply known as potential difference. I hope I made my point clear. कि आप या तो force of repulsion के against work करो या force of attraction के against work करो, whatever the work you would be doing, that will be considered to be as the potential difference if you divide that work done by the charge. इसका मतलब आप क्या लिखेंगे? So the formula simply is कि potential of point B minus of potential of point A is written as work done in moving the charge from A to B divided by the charge which is being moved. This is the definition for potential difference. Did you understand? So simply the potential difference says the work done per unit charge in moving it from one point to another point in an electric field against the force of attraction or repulsion is known as potential difference. तो क्या लिखेंगे हम? वर्क डन per unit charge in moving it from one point to another in electric field against force of attraction or repulsion is known as potential difference. ठीक है, इसको नोट करिए इस डेफिनेशन को, और ये सारी चीजें नोट करो. तो मैं एक और डेफिनेशन बताऊं. कर लिया नोट सर आप लोगों ने?
Yes, sir.
Okay, so this is basically defined as potential difference, electrostatic potential difference. ठीक है, और ये क्या है? बेसिकली जब आप एक चार्ज को you move it from one point to another point in the same electric field, then this is known as potential difference. बट अगर आप ऐसा सोचो बेटा कि इफ वन ऑफ द पॉइंट इज एट इंफिनिटी, मतलब क्या है, मतलब ये है कि देखो एक चार्ज है, ये सोर्स चार्ज है मान लो, तो इसकी इलेक्ट्रिक फील्ड कुछ डिस्टेंस तक होगी। ऐसा तो नहीं है कि इलेक्ट्रिक फील्ड ड्यू टू अ चार्ज इज अप टू इंफिनिटी, ऐसा तो नहीं होता। एवरी चार्ज हैज इट्स इलेक्ट्रिक फील्ड अप टू सम डिस्टेंस, वो मैंने आपको बताया था। जैसे जैसे आप डिस्टेंस इंक्रीज करोगे इलेक्ट्रिक फील्ड की स्ट्रेंथ डिक्रीज होगी। So at infinity, I can simply claim that there will be no electric field, there will be no force, because the formula of electric field is kq upon r square. If you put r equal to infinity, so it will become E is equal to kq upon infinity, and anything divided by infinity becomes equal to zero. So electric field at infinity is zero. This means that there is no force at infinity. So if there is no force at infinity, you don't need to apply any external force if the charge is at infinity. And if you will not apply the force at infinity, means work done at infinity will be equal to zero, and hence the potential at infinity will also be zero. तो इसका क्या मतलब है, इसका मतलब समझिए पहले तो मान लो कि there is a charge which is placed here and this charge is q naught, and this charge मान लो कि for this example I am taking this charge as negative, either it can be positive or negative, doesn't matter. ठीक है, तो ये नेगेटिव है और इसको मैं यहां से मूव करा रहा हूं, मूव करा रहा हूं, मूव करा रहा हूं, एंड वेयर आई एम टेकिंग दिस चार्ज टू, आई एम टेकिंग इट एट इंफिनिटी। मतलब मैंने चार्ज को कहां पहुंचा दिया, आई प्लेस द चार्ज फ्रॉम पॉइंट ए विच इज इनसाइड द इलेक्ट्रिक फील्ड टू अनदर पॉइंट विच इज एट इंफिनिटी। तो मैंने आपसे बोला कि इलेक्ट्रिक फील्ड एट इंफिनिटी इज इक्वल टू जीरो, फोर्स एट इंफिनिटी इज इक्वल टू जीरो, मींस पोटेंशियल एट इंफिनिटी इज आल्सो इक्वल टू जीरो। क्लियर हो गई बात? दैट इज बेटा पोटेंशियल एट बी इज इक्वल टू जीरो सिंस बी इज एट इंफिनिटी। तो अगर मैं इस फॉर्मूले में ऐसा रख दूं, VB माइनस ऑफ VA इज इक्वल टू वर्क डन फ्रॉम A टू B डिवाइडेड बाय चार्ज, तो VB will be equal to zero. Am I right? Tell me yes or no.
Yes, sir.
So VB is equal to zero. So VB minus of VA, and let VA is simply equal to V. So can I write this as V is equal to charge, sorry, work done in taking the charge from A to B divided by the charge itself. And remember, charge is also negative and V is also negative, so the two negative sign will cancel out, and finally you will get work V as equal to WAB divided by Q naught. So this is the potential of only one point, which is A, because beta VB minus of VA potential of A, because VB तो zero है, so this is simply equal to A. मतलब अभी भी आपने difference लिया है, you have taken the difference of the electric field, sorry, you have taken the difference of electrostatic potential, but that difference is exactly equal to the potential of one point, because one of the potential is zero. Are you getting what I am saying? कि अभी भी डिफरेंस लिया है बट वन ऑफ द क्वांटिटी इज जीरो, तो वी हैव गॉट ओनली द पोटेंशियल ऑफ अनदर पॉइंट। क्लियर हो गई बात? तो दिस इज नोन एज इलेक्ट्रोस्टैटिक पोटेंशियल। इट इज नॉट कॉल्ड एज डिफरेंस बट इट इज कॉल्ड एज इलेक्ट्रोस्टैटिक पोटेंशियल। तो पोटेंशियल आप कैसे डिफाइन करोगे? इलेक्ट्रोस्टैटिक पोटेंशियल इज डिफाइंड एज के इफ द चार्ज इज आइदर taken from one point in the field to infinity or from infinity to a point in the electric field, then in that case the work done divided by the charge is known as electrostatic potential. मतलब क्या हुआ सर? Whenever you define electrostatic potential, one of the point will be at infinity. Did you understand? Whenever you define electrostatic potential, out of the 2 points, one will be at infinity. Did you understand? Tell me yes or no.
Yes, sir.
Yes, sir.
Okay, what is the difference between potential difference and potential? अगर मैं आपसे पूछ लूं what is the difference between potential difference and potential, what would you reply? Sir, in the case of potential difference, the 2 points are in the same electric field, and in the case of potential, one of the point is at infinity. So I hope you have understood what is potential and potential difference. Just note this down so that we can end the today's class. Note करिए इसको.
Sir, can you repeat this electrostatic?
Yes, I'll repeat that. If one of the point lies at infinity, then potential difference is simply known as electrostatic potential, right? आपके दो पॉइंट्स होते हैं ना, जिसमें आप एक पॉइंट से दूसरे पॉइंट पे चार्ज को मूव कराते हो एंड यू कैलकुलेट द वर्क डन. So out of the 2 points, if one of the point lies at infinity, then in that case potential difference or electrostatic potential difference will be simply called as electrostatic potential. Did you understand? Everyone please respond.